So in last session, we talked about what is a vault and how does it work. But it was just an introductory area where you have seen how to install it. So let's move forward to the backend and the working of Vault, the Hashicorp Vault. So what will we learn here? So we'll learn about the installation of the Vault, how Vault works, and the basic commands for the vaults, right? For the basic commands, let's stick towards the Vault help and the Vault list secrets. So when we go for the installation step, like I said before in the prerequisite section, for Windows, you need a Chocolatey. And the command for installing the Vault using Chocolatey is just choco install Vault. Whereas for the Linux, it's basically depend upon what OS distro you are using. Let's suppose you have CentOS or an Amazon Linux. That point of moment, your command would be yum install Vault. Whereas if you are going for a Ubuntu base, then that point of moment your package manager would be apt. So it would be your apt install Vault. Whereas in Mac OS, like I said, like I showed you before, I had installed Homebrew, and via the Homebrew install Vault has been done. It would be more of like this. So since I have already installed it, it's showing me to reinstall. Now, how actually this Vault works? We have seen the architecture, but it gives us a pretty vague idea. Whereas let's move toward it having with a component-based analysis. So this is my Vault agent. This is my application. Whereas this is our S3 bucket or something. This is my Vault server where the storage backend is there. And this is my core area, the Vault core. Now, whenever any request has been raised for leasing a token or an authentication secret token, it actually move forward to the Vault server via the Vault agent. Now, the listener could be, as of now here, the listener is 127.0.0.8007, and it has been moved forwarded to the Vault core area. Now, whenever we are leasing the token again, it's done via the REST API technology. So the Vault actually had the path. So via the core engine or the path routing mechanism, it actually communicate to the storage packet to process the token of lease. Now it return the secrets lease token, and then it goes toward the app area. So once it is there in the app area, it actually gets a secret via that token, and then using the acquired credential, it actually connect with the S3 buckets. So this is one of a use case scenario where an application want to connect to the S3 backend using the secrets, which is there stored in the Vault server. So the whole cycle or the whole user flow diagram is right now in front of our screens. So first is, again, I'll reiterate, first is to request a secret lease token so that it can authenticate to the Vault storage backend. So again, then it's moved to, forward to the Vault server using the Vault agent. It goes, Vault server core area goes to the storage backend so that it can persist the token for a certain amount of time. And then the core server returns the secret lease to the Vault agent. Once it is done, the Vault agent actually go to the cache and store it in the area. Now, if it's the first time, the cache would return it to the app. Whereas if it's the recurring time, the Vault agent would be directly communicating it to the cache area. not every time it would be forwarding the request for the lease or lease token if it's there in the cache. So if it there is there in the cache, it won't be forwarding the request to the vault. So that is how a vault works, and it's simple mechanism. It's not a rocket science over here. And if it is, we are here to make it very simple for you. So yeah. So like I said before in the previous session, we had two type of servers in the vault. One is the dev server and another is a production server. So when we say a dev server actually means it's an area or it's a sandbox area where you can experiment all the vault feature which is there with a different auth method, different secret engines and different audit devices. The properties of dev server is basically so whenever in we start the vault server where all dev server, it make the whole server initialized automatically and unsealed, right? So unsealing is a thing which is done by the vault in the dev server only, and it's make the process very simpler. Whereas in the dev server, the memory is in memory storage, so it's again you don't need to require any additional storage backend. Whereas in the production, the storage backend area is in a different location. Now, the third thing is that it's bound to the local address without any TLS. So TLS certificate is one of a thing which is required when we are going for the production secure communication. Now, it actually automatically authenticate again with the CLI access. You have a single unsealed key and the key value storage is mounted, right? So this is one of a custom vault configuration which we can do. It's basically so first is to disable mlock, which is used to actually swap the memory pages in the disk. So it's actually we need to actually disable it so that there is no memory leakage. Then UI is true so that we can see the vault web UI. Initially, it's not enabled when we trigger the dev server. So it's actually never get triggered. The same point of moment, the listener address and the TLS disable. These two things are there in the TCP connection. And then we had this storage file. So the storage file is actually to specify where your backend is stored. So this would be a simple dev configuration. So like we had this in our previous session, we got this error. So let's solve it, right? Because it was giving us the connection refuse. So let's start the server. The connection refuse is a thing which happens when we are not having a specific server started. So we'll go for vault server and then dev. Once we click that, you can see we had this log over, right? So we'll first of all parse this log. Let's see. So you can see the API address is HTTP, not HTTPS. The TLS is disabled. The recovery mode is false. Your storage is in memory. And then it says, I'll go to the, yeah, this pre-seal thing is started and then the post unseal. So it actually unsealed your whole vault. And you can see the core is saying the vault is ready. So if you remember, we had this expiration manager, rollback manager, identity manager, and the core. So each and every component is giving their outputs, if you can see it, right? Now, once that is done, then let's have another terminal and see if we can had this thing running. So first of all, we'll go for vault help. You can see vault list secrets. It's again giving us that it's having the HTTPS, whereas our server is in HTTP, right? So how we can solve it? So if you can see, after our dev mode was enabled, it's saying you may need to set the environment variable. This actually tells the whole terminal that when we click on vault, at that point of moment, the request should be in HTTP mode, not in the HTTPS mode. So once we do that, you can see we get no value find at secrets. So this was the installation done in a local machine, whereas there's one more thing. So right now the world is moving toward the containerization. So in our next session, we will talk about what is a different thing when we are going for the container-based installation. Okay, so we'll meet in that session. Till then, please explore more of the world commands, the common commands over here. Thank you.